the HUMMER portable speaker. The model number is for A1200B. They said here is a 1200 watt. For no power, one charge the battery, one turn on, is completely dead. So I took the board apart and you can see these resistors completely burned. And let's check it more. This fuse is still good. Yeah, this fuse is open. We have a diode here. Oh, that's diode is shorted. 0.00 something. This diode is shorted. This one will look like okay. Yep. 0.1 if we flip. Yeah, this one is give the reading both way. Could be that one is bad as well. Zero point 0.1, 0.1, 0.1, and if we flip 0.1. So these diodes, they give a strange reading. There is another diode right here, 0.1, and if we flip 0.1. These resistors, they test good, even they are burned, but they still test okay. I see a component here is look burned. Let's go on the microscope, it's better. Okay, you can see how this resistor looks. Yeah, but still testing okay. This is the conductive material here. So this resistors is a low ohm. So just burned the top layer, but the resistor itself is this black thing is still okay. This component here is burned. That's a 431. This one is look like it's a TL 431. This one is like the optocoupler. This fuse is test open. This diode test shorted. Couple diodes here. So I'm gonna take all these diodes and measure them. Zero 0.5 open, so this one is good. This is 0. So this one is bad. Zero 0.1, 0.1 open, so this one tastes good. 0.1 open, so this one is good as well. 0.1 open, 0.1 open. So we have just one bad diode. Maybe that's the guy caused all this mess here. There is a little diode here. Just want to be sure because it was giving the reading both ways. 0.1 And if we flip 0.1, but look like the diode is connected to this relay. Open 0.5. Yep, that just like the relay diode is always like this low. So we want to be sure that these traces that's going in these areas are good, because this trace is got right here. This go all the way to here. So we can put the traces. This one here we can rebuild it. This one from this point. Let's go to this point, right? That's good. There is another trace from this point going somewhere here. But the trace still looks good. This one is good. This one is good. And this is good. So all the traces did this okay. Yeah, this is a TL 431. I don't have any SMD small TL, and in this one we have REF, and the cathode is connected together with this trace, and here we have nothing. You can see this trace is go to this resistor, and the anode is connected to this trace here. This TL is not for the feedback, not as this one right here. Yeah, you can see this one is for the feedback because it's connected to the optocoupler, but the other one is not for the feedback. This one here is not for the feedback, could be for the power on. So I jumped the fuse just to test. I put a little jumper, and so let's gonna plug the power here, and we'll plug the power. We have the light. Before we didn't have no light. And yeah, it's look like it works. So I'm going to turn it on. Yeah, nothing burned. That's good. So let's test it in the speaker. Alright, I connected the battery and the wires, and we have the red light now, not the green light as before. So the battery is charging. Okay, let me turn it on. Get ready to unplug in case if there is any fire. Now it works. It works. I have the radio here. I don't know, you can see the display here. Let me turn it off, and you're going to just watch this. You can see it is go off. Here is the display. Radio. So the Bluetooth. It works. I see some smokes. What is this one? Looks like it's coming from the resistors. Yeah, I find a smaller. You can see the REF and the cathode, both of them is connected together, and this is the anode. I'm going to take this fuse and replace it with one. Be sure that the fuse is good. It is good. after we removed the shorted diode, we fixed the traces and installed the burned up to coupler, install the fuse, connect the device turns on, the light is on, connect this battery, these resistors. Yeah, these resistors get extremely hot. Like get extremely hot, the solder point start melting. Like the resistor is gonna fall by itself. So I checked the voltage in the battery, just like 6 volt. I put it in the charge for like, let me check that battery. Yeah, I put this battery in the charge for like about 10 minutes. The battery itself is get warm, but there is no charge going to the battery. It's stuck at the 6 volt. Right, that's the battery. There is no crack in it. The battery still looks good, but the voltage in it is like doesn't want to go up, doesn't want to charge. Even it's go down by itself from 6 volt to the 4 volt. So definitely this battery is bad. I do have a small battery to test these devices, and let's plug it. And we're gonna turn, the device is on. Yep, the device is on. I'm gonna just switch to the radio.
Come on and let
It
me
works.
know.
And if I plug it, so we can see the red light. And I add these resistors. Yeah, I add these ceramic resistors to make because these resistors, they can handle the heat good. So yeah, it's still fine. It's still cold. Yeah, by this time the other battery, these resistors get very hot. And they add a thermal pad between the bottom of the board to the heat sink. So that's going to keep these resistors cool as well. Yeah, still cool now. And if we check the voltage in the battery, alright, let's see, 13.9 volt. See, the charge is going up. So definitely the device is charging the battery. And the important thing, these resistors, they don't get hot. The device is powering on. So now we have to put the device together, and that's it. So the customer got me the battery replacement, and let me show you. The part number of the battery is PS7-12, 12.5 volt. So the battery is good. So let's plug it to the device, and we're going to check if the device turns on and charging. So I power on the device. Yep, the device is on. Or to the radio. Yeah, it works. So let's plug it to the charge. And we check if the battery getting, the voltage in battery is getting up. So we have 13.8, 13.89, 13.9, 13.95, 13.97, 14 volt. You can see the voltage is rising quick, so it's charging fine. The battery won't bad, and put a lot of load in these resistors here. The resistors get very hot and causing the diode, because the component, if it's a reach high temperature, it may burn and causing a short. The diode gets short, this optocoupler shorted and blow it, the fuse burn it, and that's what is end up everything, like the device completely doesn't work. So yeah, let's put it together and we go from there. Okay, just done put the device together, and let's turn it on. We have the LED light, it works. You can see
Silhouette in the back.
Alright, if we plug it to the power, we have the battery light. So that's all for this video. Thank you for watching, and see you again.